thing we've done, and we're turning it into an equation by adding an equal sign, which means that we will be able to solve each problem and get an answer. For example, let me start here. 140 equals the square root of, let's see, 2 times 9.8. I'm just throwing a decimal in here just to show you that it doesn't really matter whether they're whole numbers or decimals. We're going to do stuff the same way. Okay. A radical equation, right, just means an equation where there's a radical in it. We've done some stuff kind of similar to this. Now, here's the deal on this. If you look at what's underneath the radical, if it's not perfect squares, and none of these are perfect squares, right, we can't take the square root of d or 2 or even 9.8, then that means we're not going to try to take the square root of it. What we want to do in this is get rid of this radical sign. Now before we do that, we could simplify underneath if we want to do our 2 times 9.8. If there's anything to simplify, you might want to simplify first. That'll probably make things easier as we go. It becomes 19.6, right? And that's a good thing to do also just in case, what if that turned out to be 25 and it's a perfect square? It didn't, but you want to check and make sure. Now I still don't want to take the square root of 19.6, and I don't want to take the square root of d. What we're needing to do here is to get the d by itself. We need to solve the equation. So like any other equation, we want to get the variable by itself. The first thing I see here is this radical is going to make things really tricky. I want to get rid of the radical. How am I going to get rid of it? How do I undo it? Diego? Yeah, the opposite of the radical is the power of 2. Now if I do the power of 2 on one side, remember I have to do the same thing on both sides of the equation. So on the right side, where I did this whole radical with the power of 2, well those cancel out, so now I've gotten rid of that radical sign there. And on the left side, I'm going to get a big number, but that's okay, 140 times 140, and I get 19,600. So if there's not perfect squares, which for most of these there won't be under the radical, then you're just going to get rid of the radical by squaring it, and make sure to square both sides. Last step here, to get the d by itself, is just divide both sides by 19.6. 1,000 equals d. Okay, so again, simplify first if you can, then undo the radical by squaring, and then you solve the equation just like you would any other equation we've been doing all year long. Now, here's when there's going to be something else to do first. Next example. The square root of 5x plus 1. As you can see, none of those are perfect squares. And we've got addition under here, so that's kind of different. And now outside the radical, make sure in your notes you show that this 2 is not underneath the radical. Plus 2 equals 6. So paying very close attention to what's underneath the radical and what isn't. Before we square this to get rid of the radical sign, we need to get rid of this plus 2. I don't want to square this whole thing because then I've got a binomial. And if this is a binomial squared and this is like a really complicated radical, that's going to get really, really difficult. So the first step is, if there's anything that's not under the radical, undo that first. And of course, undoing, remember, just means doing the opposite. You guys know that. I still have the square root of 5x plus 1, and now it equals 4. Now that it's just the radical, now I can do the same step I did in the first example. I want to get rid of that radical by squaring it, and I make sure to square both sides. On the left side, the radical and the power of 2 cancel out, leaving 5x plus 1. And on the right side, 4 squared is 16. And now we just have to solve the equation. Now it's just a regular equation. What do I do first in an equation like this that has more than one operation? Jaden?
Minus 1.
Good. We leave the variable part alone. We undo the other stuff first. So minus 1. I get 5x equals 15. And of course, I divide both sides by 5. And I get x equals 3. So once we get rid of that radical, they should look pretty similar to things you've done in the past. Now, I know how much you guys love binomials and trinomials and factoring. I know, it's true love. It's like your soulmate in math. 11x squared minus 63, all under the radical, minus 2x, not under the radical, equals 0. The good news is you're not going to actually have to factor this one in order to solve it. It will end up being a trinomial, but you're not going to have to, again, do any factoring yet. We'll get back to that soon enough. Okay, based on this last example I did over here on the right side, what do you think I need to do first here? Tammy? Yeah, we leave the radical part alone and we get rid of the other stuff first. So I'm going to add 2x. Now I have the square root of 11x squared minus 63 equals 0 plus 2x, 2x. Now I can get rid of the radical sign by squaring both sides of the equation. And again, the radical and the power of 2 will cancel each other out, leaving x squared minus 63. On the right side, be careful. I put the 2x in parentheses when I put the power of 2 on it. That makes a big difference because that means the 2 gets squared and the x gets squared. If you only square the x, you will end up with the wrong answer. Okay, now this one you're going to see here in a second, it's not even going to turn out to be a trinomial. However, I do need to get all the variables together on one side. I'm going to move the 4x squared over here by subtracting it, right, because we can't have variables on both sides of the equal sign. That puts the right side back to 0. 11x squared minus 4x squared, those are like terms. I get 7x squared minus 63, all equals 0. Now, we could try to factor this. There's some different ways we could do it. This is not the difference of two perfect squares. Okay, we could try to factor it and do it that way, but knowing that you guys actually don't want to factor, there is another way to solve it. We started doing these earlier in the chapter. If I'm going to eventually get the x by itself, we're just going to solve it like a regular equation. If I'm going to eventually get the x by itself, what do I do first? Start solving and undoing. Vincent? Good. Again, we leave the variable alone. So I'll start by undoing the 63 by adding it to both sides. Okay. The next step towards getting x by itself. Brian?
Divide by 7.
Good. Next I can divide by 7. 63 divided by 7? 9. And now, we could either take the square root of both sides to undo that power of 2, or you guys could probably do mental math on this, but just to continue the method of undoing that, square root of 9, 3. Now, let me just point something out here. Technically, the answer is both positive and negative 3. I'm not going to focus on this yet. I just want to keep reminding you of it because it does come up. I think it's in chapter 12. Yep. In chapter 12, we're going to see this a lot more, and we're going to spend a little more time focusing on it. Just keep it in the back of your mind. For now, I'm not going to require that you have that, but that any of these perfect squares, positive 3 times positive 3 makes 9, negative 3 times negative 3 also makes 9, so it technically is both. For now, for finishing up this chapter, you can just give me the positive version. That's fine. Now, I just want to show you one more, just because sometimes you get to one that looks a little different than what we've done. So one that's going to look slightly different, and then I promise we are done. 3x over 2, all under the square root, equals 120. There's nothing outside the radical on the left side, so I don't need to undo anything first. I'm going to do like the very first problem. I'm going to look at that and go, hey, none of these things under here are perfect squares. Let me get rid of that radical sign by squaring it. So just a reminder, even if it looks like this, right, it's still the same process. 3x over 2 equals 14,400, that's 120 times 120. So now we're solving again. What do I do first on this one? Carissa?
Multiply by 2.
Good, I'm gonna leave the whole 3x alone, it's being divided by 2, so I do the opposite, which is to multiply by 2. And then my final step, I divide by 3. So again, all the steps are the same, it just looks a little bit different at first, and that throws some people off. So just the same process. If there's something outside the radical, undo that piece first. If there's nothing, then start by squaring both sides, and then you get rid of the radical and you can solve, and that's it.